Hello everyone, welcome to my channel. Let's solve this question together. Now we're given what? We are given that 8 to the power of x equals to what? 6x. We are asked to look for the value of x. Now our first step, what we're going to do is to divide by what? By 8 to the power of what? X. Now if we divide here by what? 8 to the power of x, also divide this by what? 8 to the power of what? X. Now 8 to the power of x divided by 8 to the power of x will give us what? 1. Okay? Equals to what? 6x, okay, divided by 8 to the power of what? X. What are we going to do here? Let's obey one of the properties of indices. Okay, now we're going to add this is 1 equals to what? 6x, okay, multiplied by 8 to the power of what? Minus x, by obeying the properties of indices, because 8 to the power of minus x is equals to what? 1 divided by what? 8 to the power of x. Okay, now let's divide both sides by 6 because our target is to look for the value of what? X. Now this will cancel out this. Okay, we now left that 1 over 6 is equals to x multiplied by 8 to the power of what? Minus x. Now what are we going to do? We can also write this as what? 8 multiplied by 8 to the power of what? S multiplied by what? 8 to the power of minus s equals to what? 1 over what? 6. It's the same thing, there's nothing changed. Okay, now here there's amazing things we are going to do here. Okay, now we're having that x multiplied by 8 to the power minus s equals to 1 over 6. What are we going to do? Because we are asked to look for the value of x. Can this problem be solvable? Yes. Now what are we going to do? Now let's recall one of the properties of logarithm, that if you have e raised to the power what? E raised to the power what? Link what? Link a is equals to what? A. This is one of the properties of what? Logarithm. So we are not wrong if we decide to write 8 to the power minus s as, that means x multiplied by e raised to the power what? E raised to the power what? Ln 8 to the power what? Minus 8. Okay, we are not wrong, but obey the properties of logarithm, that e raised to the power of ln a is equals to a. That means e raised to the power what? Ln a, and e raised to the power what? Ln 8 to the power minus s equals to 8 to the power minus s. By obeying these properties of logarithm, all this is equals to what? 1 over what? 6. Now again, one of the properties of indices of logarithm, sorry, this power which is minus s can also go back to multiply the link. Okay, so what this is what? X, okay, multiplied by e to the power of what? Minus x what? Link what? Link 8. All this equals to what? 1 over what? 6. By obeying the properties of what? Logarithm. All these things we are doing here, we are obeying the properties of what? Logarithm. Okay, now what are we going to do? Wow. Now we're having what? S multiplied by e raised to the power minus s link 8 equals to 1 over 6. Now let's obey the what? The properties of Lambert function, that the Lambert function of into a multiplied by e to the power of a is equals to what? A. Now this is very interesting. Okay, now before we can take the Lambert function of this equation of both sides, now we're having x here. This s you are seeing here is like this a you are seeing here, and this e is this e you are seeing here, and this multiplication sign, you can see multiplication sign here, but the power here is minus s link a, and what is we are having here is just a. So how are we going to make this to be equals to this, so I can take the Lambert function on both sides? So what you have to do is to multiply both sides by what? By minus what? Link 8. Okay, so that means if you multiply this by what? X multiplied by minus link 8, okay, multiplied by e to the power what? Minus link 8, okay, equals to minus link 8 multiplied by 1 over what? 6. You can see that we multiply both sides by minus link 8. Now x multiplied by minus link 8 will give us minus s link 8 multiplied by e to the power what? Minus x link 8 equals to minus 8 minus link 8 divided by what? 6, because minus link 8 times 1 is less than minus link 8. Now for here we can take the Lambert function, because consider minus link 8 is equals to what? The exponent here, which is minus link 8. That means the Lambert function of into minus x link 8, okay, multiplied by e to the power what? Minus s link 8, okay, equals to what? The Lambert function of minus link 8 divided by what? 6. Now you can see that we are taking the Lambert function on both sides. Now the outcome of this will just give us what? Remember that the Lambert function of a multiplied by e raised to the power of a is equals to a. That means the outcome of this is just minus x link 8 equals to the function of what? Into minus link 8 divided by what? 6. Now let's divide both sides by link 8. So if we divide here by what? Link 8, also divide the whole of this by what? Link 8. Okay, now this will cancel out this, we all agree. Okay, now see that minus s is equals to the derivative function of what? Into minus link 8 divided by 6 all over what? Link 8. Now remember, we are asked to look for the value of x. Okay, we are asked to look for the value of x. Now, but we are seeing that minus s is equals to this. So what are we going to do so that we can remove this minus sign from here? We have to multiply both sides by what? By minus 1. So we can remove minus sign from the x. So we can look for x. Now, if we multiply both sides, multiply what? Multiply both sides by what? By minus 1. So let's multiply both sides by minus 1. Okay, if we do that, we're going to have that x is equals to, because minus 1 times s will give us x, equals to minus the real function into minus link 8 divided by what? 6 divided by what? Link 8. And this is the value of s to this particular problem. Remember, it's not all calculators that have these properties, this function, this operation. Okay, so what I'm going to do, I'm going to draw the answer on the screen. As you can see here, this is the answer. Okay, remember that the Lambert derivative function you are hearing about. Okay, remember that the Lambert derivative function you are hearing about is the what? It came from what? The definition. The definition of Lambert derivative function came from what? The inverse function. Remember that the derivative of x, you look at the derivative of x you are hearing about today. Okay, it came from what? The inverse of a function f of x. F of s equals to what? S multiplied by e to x. Now, from this definition, that's why we are coming about what? Lambert derivative function. The reason why we are applying Lambert derivative function in some problems that look so dangerous is because when you are having s multiplied by e to x, okay, you have to take the Lambert derivative function of both sides so you can have the value of s. That's why in place of this, you can see that yeah, there's nothing you can do, but you can see that Lambert derivative function help us a lot. So Lambert derivative function you are hearing about help us in some difficult question. Okay, Lambert derivative function will resolve it for us. You can see what he did here. Very interesting. Okay, what operation can you use here to perform here to have this value? But consider Lambert derivative function help us a lot. So thank you so much for watching. This is the value of x. Okay, so what I'm going to do, I'm going to draw the answer on the screen as you can see here. Okay, so thank you so much for watching. Please, if you find it very interesting, don't hesitate. Do well to like, comment, and share it to loved ones so others will learn from it. Please, if you're not subscribed, consider to subscribe to this channel so when another exciting video, you'll be notified. So thank you so much, and God bless you. Bye.